Good afternoon. For me, I just wanted to kind of make one last set of calculations here. Okay, last set of calculations is that we're gonna deal with in eddy current. Standard depth of penetration, at least for right now, just basic numbers. Okay, this isn't necessarily going to be the most perfect thing. This isn't necessarily always going to be perfectly correct, but this is going to give us a good, whoops, trying to get everything kind of centered for you here. This is going to give us a good view of what's going on in a part. Okay, you remember from everything we've talked about so far, eddy currents are coming down like this, and you can view this as percentage or amount of eddy current. So if we said we could measure this amount, we would call that 100% of surface density. Okay, so let's say we got a part, there's our surface. Well, you get the picture. I'm not the best artist, but you get the picture. So there's the surface of our part, here's the back surface of our part. These eddy currents are going to get weaker and weaker, and they're going to continue to get smaller and smaller. Okay, all the way down. Again, you get the picture. I'm not the best artist. But at some point here, this number is going to be 37%. Okay? That 37% is relative density from the surface to where you're located. Okay? So that's the first standard depth. And then again, if we wanted to use that 37 and keep on going and going, down here somewhere we would hit roughly, now I say roughly because it's actually not exactly 14, but 37% of 37 is somewhere around the 14% mark. So second standard depth, and then down here somewhere we're going to hit 5%, roughly 5%. Okay, so there's our third standard depth. This guy right here is important to us. This is going to be what we call the effective depth. Okay, and that effective depth is something that we need because eventually at that 5% mark, any signal that's down there is not going to be enough to give us a good view or a good movement on our screen. So we say that 5% current density, the effective depth, means that there's not enough eddy currents left to really give us a usable signal. So anything past that down here is all wasted time and energy. Okay? So we could change this mainly with this right here. Okay? Frequency. We say if we raise the frequency, go from 100 kilohertz to 1 megahertz, all this is going way up here. Okay? If we lower the frequency from 100 kilohertz to 50 kilohertz, it's coming down here somewhere. Okay? So that's one way. We can also change it with conductivity, and then we can also change it with permeability. So, basic stuff there. Frequency, conductivity, permeability. Those three terms are going to be what controls our eddy current depth of penetration. So, got all that. Keeping those things in mind, we're going to go to this right here. I know this isn't perfect, but standard depth of penetration equals 1.98, because we're going to deal with inches, times the square root of resistivity divided by frequency times some relative permeability. Now there's some constants, but this has been kind of revamped for ease, at least in the classroom. Understandable terms. Resistivity, frequency, okay, like I said, these aren't the actual pretty units that you see out in eddy current terminology, but these are usable units for the classroom. Resistivity, frequency. This is really relative permeability of magnetic materials, okay, and non-magnetic materials. If it's 1, that means it's a non-magnetic material, because if we multiply it by 0, we would lose that, and if we lose that, it wouldn't do us any good. So, anyhow, we've got resistivity, frequency. Let's just work one of these out. Let's just say we have a resistivity, and you can get these directly out of your books. Okay, your gray books, they'll give you values of resistivity. We're just going to take one of those and plug it in to say we have a resistivity value, relative value of 17. Okay, and you can get that right out of one of your charts. I don't have my book on me, but you can get that right out of that chart. Alright, and a frequency of 100 kilohertz. Okay, so that's going to be 100,000. 17 divided by 100,000. is 1.7 e to the negative 4, so we'll convert that to 0.00017. 1, 2, 3, 4. That works. And now we're going to square root that, because this is all under a square root. Okay, still under a square root. So we're going to square root that answer. That's going to take us to 0.013. All right. Now we've left this behind, so 1.98 times 0.013. Push the right button here. That's going to get us pretty much directly to 0.026. Okay, closely related to 2.0, but basic stuff they're saying we're at 26 thousandths of an inch. Just want to make sure you can still see all that, which you can't see that down here. So let's back that out a little bit. There we go. So here's our standard depth of penetration formula. Here is our numbers. Okay, we just made these numbers up. This would be our resistivity value. This would be our frequency value. And I don't have my units on here, but technically we would need units. There's what this equals. Square root that. Okay, 13 thousandths. We're in inches, so we multiply by 1.98. That represents 26 thousandths of an inch. That means that if you could measure that little finite value, you would go surface of the part, okay, surface of the part, down this value right here, 26 thousandths of an inch. Eddy currents are coming down like this. Means we start off with 100% at the surface, and then down here we're at 37% of the surface density. That's our first standard depth. That's what that means. Okay, and then from there this is going to get weaker and weaker. Whoops, maybe we should keep it weaker. And then weaker, weaker. All the way down. So down here this would be 14%. Down here this would be 5%. Alright? So standard depth of penetration, basic eddy current stuff, just showing you how deep those eddy currents are penetrating in a piece. Any questions, concerns? Really, that's pretty simple math. That should be up there. Really easy to work, along with all the rest of them. Resistance and Ohm's law, impedance and inductive reactance. So just another one of those values to let you see how all that stuff comes together. Okay? If you've got questions or concerns, you know what to do. Don't hesitate to email me or call me, and we'll help you out as best we can.